बिस्मिल्लाहिर्रहमानिर्रहीम। इससे पहले जो वीडियो था उसी में हमने क्वेश्चन नंबर 7 तक डिफरेंशियल इक्वेशन सॉल्व किए थे। नाउ वी हैव टू सॉल्व क्वेश्चन नंबर 8। एक्स स्क्वायर dy प्लस वाई इंटू एक्स प्लस वाई dx इज इक्वल टू 0. We can write this differential equation as this way. Now writing this differential equation in this way, so if we look to this differential equation, here we have a function in the numerator which is homogeneous function of degree 2. xy is a term of degree 2. Similarly, y into y square is a term of degree 2. X square is in the denominator, we have x square whose degree is 2. So in the numerator we have a function of degree 2 as well as we have another function in the denominator whose degree is also 2, and finally the degree of this differential equation is 0. So we can say that this differential equation is homogeneous differential equation of degree 0. Now we can write this differential equation in terms of y over x, or we can directly put, that is, we can replace y by vx. So let y is equal to vx, differentiating we get this one. Now putting the values, this is here we have value of dy by dx, and here we have value of y. We will put these two values in this differential equation. So putting these values in given differential equation, we have dy by dx. For dy by dx we put its value. Similarly, value of y is vx, value of y is again here vx. Now simplifying vx into x is equal to, that is, now taking x common, cancelling x square with x square. So if we take this x common, it will be x square, this x square, and these two will be cancelled. This will be the remaining. Now taking minus v inside, you will get minus v into minus v square. This minus v into v is equal to minus v into v is equal to minus v square, and this v is here. This v on transposing to the right side will become negative. Here we get minus 2v minus v square. Now taking minus v common, now we have, this is our differential equation separating the variables. So we will get dv divided by v into v plus 2. This minus will be here, and x divided by dx will be here. Now we will transpose this negative term to the left side on integration. So this is the integration. Now we will find value of this thing by partial fraction, and integral of 1 over x is log x, integral of 0 is equal to c. So in the next page we will put value of this thing, value of this will be log x, this will be c. So solve this first integral by partial fraction method. So this is the method, multiplying by v into v plus 2, which will be cancelled. We will get 1 here, a into v plus 2 plus b into v. Now let us take this v equal to 0 and put v is equal to 0 here. We will get 1, and here we will get 2v, and this dv term will be vanished on account of v is equal to 0. Now value of a is equal to 1 over 2. Value of a is equal to 1 over 2. So this value of a will be here, 1 over 2a. Here this term will become 1 over 2a. Now let v plus 2 is equal to 0, that is v is equal to minus 2. Putting v is equal to minus 2 here, v plus 2 0. If we put v plus 2 0, this term will be vanished, and here we will put v, which is minus 2. V is equal to minus 2, so minus 2b is equal to 1, or b is equal to minus 1 over 2. Here we will get b is equal to minus 1 over 2. So value of a and b will be substituted here, and then we will take integration of both sides and will try to find where of the right side. After finding the value, we will put the value here. Hence we will proceed to the next slide. This value of this thing is equal to a. Value of a is equal to 1 over 2. Similarly, value of a is equal to 1 over 2. Value of b is equal to minus 1 over 2. So putting here, for a and b both have 1 over 2, so we will take it common, and here we will get 1 over v minus value of b is minus 1 over 2, so minus will be here and 1 over 2 is common. Now taking integration of both sides, here integral of 1 over v is equal to log v, integral of 1 over v plus 2 is equal to log v plus 2. Now log v minus log v plus 2 will become log v divided by v plus 2. So this is value of this integral is equal to 1 over 2 log v divided by v plus 2. We will put value of this one here. We will put the value which we have obtained this time. We will put that value here, and we will get, this is the value of the first integral is here, integral 1 over x dx is here, integral 0 is equal to this. Now multiplying both sides by 2, so this 2 will be cancelled. Here we will get 2, here we will get 2c1. Now replace 2c1 by another constant c2. This 2 will be shifted here. Now we have log of a plus log of b, which can be written as log of ab is equal to c2. Now this is logarithmic form. We will write this log form as exponential form, so we will get this one is equal to e power c2. Now this v will be replaced by its value, and this e power c2 will be replaced by another constant. Now simplifying y plus 2, this x will be here, so we will get y plus 2x, and this x here 1x will be cancelled, so we will get yx, and this x will be shifted to the numerator. Finally we will get x square y divided by y plus 2x is equal to c3, and we can write yx square is equal to c3 times y plus 2x. So this is the general solution of question number 8. Now we come to the next question. Here we have another question number 9. This is m dx plus m dy is equal to 0. M dx plus n dy is equal to 0, where m is equal to this one and n is equal to minus x. These two are the functions. These two are homogeneous function of degree 1. Here if we have to calculate the term of the degree of this term as well as degree of this term, degree of this one is 1, and here the degree of xy under root multiplied by 2. The degree of this first term is also 1. We can also check the degree of this function by replacing x and y by tx and ty, and we will get that the degree of the function m is 1, and similarly here the degree of n is 1. So both the functions are homogeneous function of degree 1, and the differential equation will be homogeneous differential equation of degree 0. So this is the differential equation. We will put, let y is equal to vx. This is a little bit a changed method. Here a little bit we make some changes in the methodology. However, basically this method and the previous method is the same. So let us take y is equal to vx. Now taking differential of both sides. So this is, here we see differential. Now using product rule of differential, so v first differential of second plus second differential of first. So dy, that is the differential of y is equal to v dx plus x dv. Now putting the values in the differential equation. Here we have value of y. We will put this value of y in the differential equation. Similarly, we will put this value, which is value of y. Value of y dy is equal to this one. We will put these values in the differential equation. Equation 1, this is equation 1, becomes, by putting the highlighted values, this will be the putting, now taking x common. Here we have x, v under root x square under root. Here we have x, which is common. Here vx, x is here, this x is here, and these are the remaining terms, dividing both sides by x and simplifying. So this is the value. This term will be here, minus v dx, minus v dx. Both the terms are identical, so we will add both the terms. Minus v dx, both will become minus 2v dx. Similarly, this minus x dv will be here, and finally we will get equal to 0. Now making some calculation, this term will be transposed to the other side, separating the variables. So these are, here we see the variables have been separated, and making some arrangement. Here we get 1 over 2. Here we will take negative sign common, so we will get v minus v under root, and the common minus will be here, and here we will get 1 over x dx. This side is here, and this negative, on account of this negative we will transpose it to the other side, so both the terms are here, which will be 0. Integration of first term plus integration of second is equal to integration of 0. Integral 1 over x is log x. Here if we take v under root common, so we will get twice v under root, and here we will get v under root, and this v under root have been taken common, so here we will get minus 1. Integral of 0 is any constant. Let us take that constant equal to log c. Now we have to find value of this integral by substitution method. Let v under root is equal to z, taking differential, so differential of v under root is equal to differential of z. Differential of v under root is, first find its derivative and then multiplied by differential of v, and is equal to dz. Simplifying, this is the value of the differential. If we have to find differential of both sides, this is the final value. Now we will put all the values. We will put value of this. We have to find value of this one. We have to find value of this integral. So let us represent this integral by I, and this is the integral whose value has to be determined. Now we can write integral 1 over v under root minus 1 n to 1 over twice v under root into dv. Now putting the values, v under root is equal to this, v under root is equal to z, so integral 1 over z minus 1, and integral of 1 over twice v under root dz, which is here. This is here we have integral of here we have 1 over twice v under root is equal to d v is equal to dz. So we will write here, this is the value. Looking here, we will replace this thing by dz, so we will get integral 1 over z minus 1 dz. Integral of 1 over z minus 1 is equal to log denominator. This is f and this is f dash, so we will get log of denominator. Now putting value of z is equal to v under root, so we have determined value of this integral. This integral has been denoted by I, whose value is log of v under root minus 1. Now we will put this value in equation number 2. Equation 2 becomes, so log x, this here we will get log x, this value will be here, and here log c, so this is log c. Now writing log of a plus log of b is log of ab is equal to log c. Now cancelling log, this log and this log will be cancelled. This is the result. Now we will put value of v, so putting value of v, this v is y over x under root minus 1 is equal to c. Now writing this is x into y over x under root minus x is equal to c. Now we can write this x is equal to x under root into x under root into y over x under root minus x is equal to c. Now cancelling this x with this one, so we will get x under root into y under root, which is xy under root minus x is equal to c. This is the required general solution. We have already explained about homogeneous function and homogeneous differential equation. These are few questions. Let's repeat these few questions related to homogeneous differential equation. Homogeneous equation, the function which can be expressed in the form f of y over x is called homogeneous function. Any function which can be expressed in the form of y over x is called homogeneous function. So if we have a function f of x y, if we replace x and y by t x dy, and if we simplify, suppose we get t power n f of x y, then that function is called homogeneous function of degree n. The index here will represent the degree of the homogeneous function. Similarly, in this way we can say about the whether a differential equation is homogeneous or non-homogeneous. Always a homogeneous differential equation will always the degree 0. For example, here we have a differential equation. We can take x square common. If we take x square common from the numerator, and if we cancelling that x square from the numerator and denominator, we will get 1 plus y over x whole square divided by 2. This here we see a function in terms of y over x. So the given differential equation is homogeneous differential equation of degree 0. Here in the numerator we have homogeneous function of degree 2. Similarly, in the denominator we have homogeneous function of degree 2. Both the degrees will cancel each other, and finally we will get the degree of this homogeneous differential equation is 0. remember the degree of homogeneous differential equation will always be 0. Now here we have a problem. dy by dx is equal to this one. This is if we take x square common, and if we cancelling x square, this is the final value. Now replace y over x by v. We can write this as y is equal to xv. Differentiating this equation, this is the value of the differentiation. Now we will put value in the differential equation here. This y over x, this is here we will put this value here. Similarly we will put value of dy by dx. This value will be substituted here. We will substitute value of dy by dx. Value of dy by dx is this one, which will be substituted here. Value of y over x is here, which will be substituted here. So finally, after substitution, we will get the differential equation is v plus x dv by dx is equal to 1. This is 1. Y over x is v square divided by 2. Now simplifying this, we will be transposed here. Now taking LCM, so we will get 1 plus v square minus 2v. Here we have a square plus b square minus 2ab. This is the a plus b whole square formula. So we will get v minus 1 whole square divided by 2. Now separating the variable, here x dv by dx is equal to this one. Now we will separate this. This is one side, which is equal to this one. Now we have to separate the variable. Here we have two variables, the variable x and the variable v. So separating the variables, now integrating both sides. So integration of left side is equal to minus 2. Increase the power minus 2 by 1 and divide by the power of 10, and we will get after simplification this one. Integral 1 over x is log x plus some constant. Now putting value of v and simplifying, we will get minus 2x divided by 1 minus x is equal to log x plus c, or we will get minus 2x divided by this minus. This minus will be, if we take minus from the denominator, then that common minus will be cancelled with the minus here, and we will get 2x divided by x minus y is equal to log x plus c, and we can further write this as 2x equal to x minus y into log x plus c. So finally this is the general solution. This is the general solution. Here we have another question. This is a question, we can write that question in this way. We can write xy as x square into y over x. Similarly, we can take x square common. We can cancel x square from the numerator and denominator, and this is the value. Now anytime if we can express a differential equation in terms of y over x, then the given differential equation will be homogeneous at degree 0. So the equation here is homogeneous. This equation is homogeneous because it is expressible in terms of y over x. Now replace y over x by v. This equation can be written in this way, and this is the differentiation of both sides. Now putting the values, if we put the values in the differential equation, we will put this value in the differential equation. Similarly, we will put this value in the differential equation. So we will get v plus x dv by dx is equal to v divided by 1 minus v square. This is the value v. This y over x will be v. This 1 will be here. This y over x is v whole square, and this is division, v divided by 1 minus v square. Now simplifying this, we will be shifted here, taking LCM. So we will get v minus v, this is minus v minus v into minus v square is equal to v cube. We will get cancelling these two terms, v cube divided by 1 minus v square. Now separating the variable, here we have, this is one side, this is another side. We have to separate its value. These are the values which have been separated. Now we can write this left side in this way: 1 divided by v cube minus v square divided by v cube is equal to 1 over v. Integrating both sides, integration of 1 over v cube is equal to minus 1 divided by 2v square. If we integrate integration 1 over v cube, this 1 over v cube will be integral v power minus 3. So increase the power minus 3 by 1 and divide by the power. So we will get minus 1 divided by 2v square. Integral 1 over v is log v. Integral 1 over x is equal to log x plus some constant. Here the constant is log c. Now writing this as log cx and putting the value of v. So simplifying, we will get minus x square divided by twice y square is equal to log of cx plus log of y divided by x. This term is and because of this term have been transposed to the right side, so it is here. Now log of a plus log of b is always equal to log of ab. Now cancelling x, so we get log of cy. So here we get minus x square divided by 2y square is equal to log of cy, which is, this term is here. Looking, this is here and this one is here. We will further simplify, so we will get minus x square, this 2y square will be shifted here, and finally this is the general solution. Here we have another question: 2 dy by dx is equal to dy over x plus y square divided by x cube. This is the question. We can write dy by dx. This 2 will be removed from here and it will be shifted to the other side, which is here. Now replace y over x by v. Here we see that the given differential equation has been written in terms of y over x. So the differential equation is homogeneous. Now we have to replace y over x by v. We can write this equation as y is equal to xv, and we can differentiate this equation to get this one. Now we will put the values in the this differential equation. Here we have, this is the differential equation. We have to put the value here. This y over x, this will be put, and similarly we will put value of this one. These two values will be put here, and we will get v plus x dv by d is equal to y divided by x. Y over x is equal to v, and this 1 over 2 is here. Similarly 1 over 2, and this is v square. Now simplifying, this v will be shifted here, and simplifying, v divided by 2 minus v over 2 minus v is equal to minus v over 2. Now taking LCM, taking v common, separating the variables. Here we have this one and we have this one. We will separate the variable, so we will get twice dv divided by v into v minus v is equal to 1 over x dx. Now writing, we can write this left side as this one, 2 divided by, if we take partial fraction, value of this thing by using partial fraction is twice v minus 1 minus twice over v into dv is equal to dx over x. Integrating both sides, so integral of twice v minus 1 is equal to twice log of denominator minus integral twice over v dv is equal to twice log of denominator. is equal to integral of 1 over x dx is equal to log denominator plus some constant. Here the constant will be taken as log c. Now simplifying, this 2 will be here. Similarly, this 2 will be placed here. So log of a minus log of b is equal to log a divided by log b is equal to log cx, cancelling log. This is the value. Now replace v by its value and making simplification, we will get y minus x whole square divided by x square. Here we have y square divided by x square. So we will get y minus x whole square divided by y square Here in this numerator the denominator will be x square. Here in this denominator the denominator will be x square will be cancelled, and we will get y minus x whole square is equal to cx, and the denominator here we get cx, and this y square will be shifted here, so this is y square. A little bit simplification is here which can easily be traced. Another question, this is a question x writing. This is the given question, shifting this x to the other side, so we will get dy by dx equal to y divided by x. This x is on account of this x. Here we will take x common, 2 divided by x. This x is on dividing both sides by x. This one, now taking x square common from here, so x square, if we take x square common, that x square under root will be equal to x. That x and this x will be cancelled, we will get 2, and here we will get y divided by x whole square minus 1. Now the given differential equation has been expressed in terms of y over x, so this equation is homogeneous. Now proceeding as usual, we will replace y over x by v and dy by dx by v plus x dy by dx, putting the values. These are the values. Now making simplification, this v and this v will be cancelled. This is the in other words, we can transpose here, so this one, this and this cancelled. Now separating the variable dv, this dv will be here and this will be shifted here, and this x over dx will become dx divided by x, and this 2 is here. Now separating, now taking integral of both sides. Integral of this is equal to integral of this. Integration of this one is equal to log v plus v square minus 1 under root. Integral of twice d divided by is equal to twice log x plus log c. Now this can be written as log x square. Log x square plus log c is equal to log x square c. Now cancelling log, this is the value. Now replace v by its value and making substitution. Here we will get y square minus x square under root divided by x square under root. X square under root will be equal to x. Now multiplying both sides by x, so we will get y plus y square minus x square under root is equal to cx cube. अब यहाँ पे now looking equations reducible to the homogeneous form, इसी पे I have composed 2 videos on this topic, equations reducible to the homogeneous form. इस पे हमने 2 वीडियोस ऑलरेडी बनाए हैं, तो लिहाजा इसी तसलसल में हम इस पे वीडियो नहीं बनाएंगे, ये ऑलरेडी हमने बनाए हैं। तो अभी तक ये जो हमने पढ़ा हमने पढ़ा होमोजीनियस डिफरेंशियल इक्वेशन। अभी ये जो नज़र आ रहा है ये है इक्वेशन रिड्यूसिबल टू द होमोजीनियस। पर हम ऑलरेडी इस पे हमने वीडियो बनाए हैं, लिहाजा इसको हम नहीं बनाएंगे। इससे आगे जो टॉपिक है उसको हम पढ़ेंगे। थैंक यू।